The other day I was talking to somebody who mentioned they didn't even fully understand what a server is and what it does. And this was coming from somebody that I consider to be fairly technical. Hey TechKnowStuds, in this video we're going to cover what a server actually is. And here is a hint. This right here is a physical server. I wouldn't consider this even the most important part of what a server is. So let's get into the details of what is a server. A server is an important part of today's technology. A server delivers different services to us. We would request a service and then the server would deliver that service to us. As an example, if I were to go to a restaurant, a server would come and take my order. They would then submit that order to the cook. Once my food was prepared, they would then deliver that food to my table. That server is performing a service for me. Similarly, this server would deliver services for me. I would set this up to deliver certain services. Now, I look at a server as being three layers. There is the physical layer here, there's the operating system on here, and then there is the application that's actually delivering the services, the program that's actually delivering the services to me. We're actually going to start out by talking about the application because the application is the most important part of this. That's what's actually delivering the services to us. Let's talk about the application. We're going to briefly mention about the operating system that goes on this and what the difference is between the operating system is of a server and a regular client. And then we're going to get into the physical equipment and what makes this different than a regular computer. Here on the right side, we have some servers, and they are going to provide services for a client. This is why this is called a client-server relationship. And what will happen is that this client will request some sort of services from the server, and then those servers will deliver that service. So what could these services look like? Well, one of the services might be a DHCP. This machine needs an IP address, and perhaps it's requesting an IP address from the servers. Or maybe it's trying to resolve a domain name. That's DNS services. Or perhaps it's requesting a web page. So there are web services that are being delivered. On this client machine, we would find some sort of software that's making that request. On the server, we would find some sort of software that is then responding to that request. If this user is trying to access a website, they're going to open up a browser. Something like Firefox, Safari, Edge, Chrome, and that browser is the client app. And that client app then is going to make a request, and it's going to go to the server. And the server is going to respond. And it's running some sort of server app, something like Apache, which is a website services. And so that's what's going to be delivering the website to the client. On your Windows machine, you can open up Windows and type in services. This is going to show a list of different software that's running on your computer. One of the examples I gave was the DHCP service. Well, here's the DHCP client. That's the app that's running on this machine that's requesting DHCP services. If I were to go to the server that's providing this DHCP services, I would see a DHCP server. Similarly, we can see that there is a DNS client on here. So really, the key to this client-server relationship is the software, is the client software that's making the request and the server software that's responding to that request. So if that's the case, why do we have separate hardware? And why do we have separate operating system? Because I could actually take a Apache, which is what delivers web pages, and install that on any machine and get it up and running. So why would I want a separate physical hardware? What is the difference with that? Well, this is specialized. This is to deliver certain services in a more efficient manner. So let's cover that from both a software, from the operating system perspective, and the hardware perspective. Let's take a look at the services console of this Windows machine. Now, if I were to look through this, these are all the applications that are running on this machine. And we can see things like this DHCP client and the DNS client, in which I pointed out earlier. But we see a lot of other software. Now realize that this is a Windows machine. It's really designed for end users, to interact with end users. And so a lot of the software that's running on here is to create a very positive experience for those end users. But it does slow down your computer some, and it can cause some problems and conflict issues. And so when you're talking about a server operating system, something like Microsoft Server, you will find that the base programming is actually very similar, but the services that are running can vary quite a bit. That a lot of the services that are running on this client operating system, you will not find on a server operating system, and vice versa. A lot of the stuff that you find running on a server operating system, you won't find on a client operating system. So they're really tuned for what they're designed to do. So the server operating system is really streamlined to provide services in that client-server relationship. Same thing is true for the hardware side of things. So let's get into the really cool part. I love playing with the hardware. So let's jump into that. So one of the first things that you may notice with this is that we have a very thin profile and very long. And this is designed to put on a rack with a lot of other servers. Now, not all servers are set up this way, but a lot of them are rack mountable. So they're meant to be on racks with lots and lots and lots of other servers. And it's streamlined, even the cooling and all the power and all of the components of this are set up to be uniform with other servers. Another thing that you may notice is there's a lot of duplicate stuff on here. Each one of these are fans, and so we have many different fans that are on here. We've got multiple CPUs. We've got multiple power supplies with this. Here's the hard drives right here. There's a spot for 8 different hard drives that are right here. And a lot of these things are hot swappable. So I could actually take a drive out while this is running and it would still be up and running. Or I could take the power out of one of these and then this would still be up and running because I have another power supply right here. So there's a lot of redundancy that's built in with this. Another thing is that these components that are in here are also more robust. So when you find like hard drives, they're usually built a little more robust than your standard different components on a regular computer. These processors are a little more robust. The hardware on here is really meant for being up and running all the time and with no breaks. And so you get a lot more longevity out of the components of the server. Not only are our components on a server usually a little more robust and can handle a little bit more, but they also can operate at a higher level. Our input-outputs on our hard drives tend to be much faster. We use RAID controllers for those hard drives, so that way we can stripe across many disks and get more speed out of them. We have Xeon processors, which can handle a lot of threads all at once and do a lot of processing all at once. We have 24 DIMM slots here with a total of 1.5 terabytes of memory that we could put into here. So 1.5 terabytes of memory. That's just, and this is an older server too. And so we can put a lot of memory into these. The network interface cards operate at 10 gig speed, so they're much faster. And then we actually have a special interface back here as well. It's on this particular one, since this is a Dell server, this is the iDRAC, and we can manage this server. So I could connect to this server through this interface back here through Ethernet and control all aspects of this server even when it's turned off. So I could actually get onto the server and turn it on. And you really just can't do that with a remote, with any kind of desktop machine. You have to have it on before you can even remote into it, where this machine you can remote into it even when it's off. So a lot of control over there. Now, it does have some limitations. The server does have some limitations. For instance, usually your servers don't really need to have a lot of graphical calculations that are going on with it. So this doesn't really have a high GPU could put something in here, but there's really not even space for a good GPU card on here. So we don't have good GPU processing with it. There's not a lot of expansion slots with it because it's not designed for the expansion of this machine. So there are some limitations with it, but as you can see, there's a lot of cool stuff that they cram into this little space right here. So as you can see, it's not necessarily a real simple answer of what is a server. Because it really, when you render it down, it's that application that provides a service to the end user. But we have an operating system and a hardware that's specifically tuned to help provide excellent services to our end users. And it's one of the reasons why I really love this IT industry. I really love my career and what I've got to experience because you get to play with cool tools like this, and you get to set up servers that have terabytes of memory inside of it to deliver awesome services that people can get from around the world. It's still just quite amazing to me. So I hope you enjoy it as much as I do. It's really cool stuff to work with.